They built a whole road in China in like a very short period of time, just using robots and AI. So this is no humans, man.
A new era of construction has arrived, one that could reshape how we build the world. Chinese engineers have just shocked the world, as on the Beijing-Hong Kong-Macau Expressway, 10 AI-powered machines took control, paving 157 kilometers with precision that humans could only dream of.
China, you go there now, roads, bridges, schools, you never saw anything like it. They have bridges that make the George Washington Bridge look like small potatoes. And they're all over the place.
How do these machines operate autonomously? What does this breakthrough mean for the future of infrastructure?
The world's biggest tunnel boring machine to an abrupt halt. It's just 1,000 feet into a tunnel that's planned to be almost 10,000 feet long.
Join us as we explore China's autonomous paving revolution and witness the machines that are redefining construction. Surviving the Carmageddon. China's Golden Channel, the Beijing-Hong Kong-Macau Expressway, has long served as the nation's economic spine, linking the industrial south to the commercial north. But it has also been the stage for chaos. In 2015, during National Day celebrations, a toll station collapsed in logistics, squeezing 50 lanes into 20, trapping millions of vehicles in a traffic nightmare the world called Carmageddon. For China, it was more than gridlock. It was a wake-up call, proof that expanding roads was no longer enough. The future demanded intelligence, not just size. Nearly a decade later, that lesson became reality. On a 157-kilometer stretch between the Henan-Hubei border and Junshan, China launched the world's first large-scale semi-autonomous paving project, a milestone in engineering and automation. What began as a simple reconstruction became a glimpse into the next era of infrastructure. At sunrise on September 27, 2024, 10 unmanned colossal machines rolled into formation. Leading the convoy was Sany Heavy Industries SAP-200C10, a 20-meter-wide paving titan, followed by a fleet of synchronized rollers and compactors in a flawless 1+3+3+3 sequence. Guided by China's Beidou satellites and an advanced low-latency communication system, the machines moved as one, their coordination tighter than any human crew could achieve. Each unit operated with centimeter-level accuracy. The paver laid molten asphalt in continuous, precisely measured layers, while sensors tracked temperature, density, and surface texture in real time. Artificial intelligence adjusted every movement, pressure, speed, and angle, ensuring a seamless surface with no gaps, no uneven edges, and no second attempts. Among the most striking breakthroughs was zero-edge rolling. For decades, human operators struggled to compact the outer edges of highways without causing cracks or deformations. The autonomous rollers solved it entirely. Through precise path-tracking algorithms, they compressed every millimeter of asphalt to perfection, edge to edge, every time. Safety, however, remained the ultimate test. With no human oversight on the ground, each machine was enclosed in invisible electronic barriers, supported by radar, cameras, and redundant emergency systems. Every potential hazard triggered an automatic slowdown or shutdown, creating a worksite where control was absolute and danger virtually non-existent. The outcome was historic: faster construction, higher precision, fewer risks, and reduced costs. But more importantly, it marked a strategic leap toward China's vision of intelligent infrastructure, a world where machines not only build, but also think. Across the globe, the shockwaves were immediate. The European Union began studying China's autonomous construction methods. Japan accelerated development of its own robotic systems ahead of the 2030 World Expo. Even the United States, despite tensions, quietly launched similar research through its Department of Transportation. The autonomous construction race is on, and China is leading it. The timing could not be more critical. As the planet faces mounting infrastructure demands, workforce shortages, and the rising cost of climate resilience, automation offers a powerful solution. Machines don't tire, they don't age, and they can work in conditions too harsh for humans. Now, engineers are analyzing every byte of data from the 157-kilometer experiment to refine algorithms and push automation even further. As international manufacturers scramble to catch up with automated road construction, China has already moved ahead, utilizing AI to complete another road that has stunned experts worldwide. The world's highest highway. High above the mountains of Guizhou, China, is a structure that redefines modern engineering, the Huajiang Grand Canyon Bridge, now the world's tallest bridge. Rising 625 meters from the canyon floor, it links two cliffs, once separated by hours of winding, dangerous travel. What once took more than 2 hours to cross can now be completed in under 2 minutes. This megastructure was created through a fusion of human expertise and artificial intelligence, a first-of-its-kind achievement that turned one of China's most complex landscapes into a showcase of digital construction. At its core was an AI-driven intelligent construction system, powered by China's Beidou satellite navigation network. This system enabled machines to operate with centimeter-level precision, automatically guiding cranes, cable hoists, and truss-lifting systems across the canyon's expanse. Every movement, from lifting steel segments to aligning bridge joints, was controlled through AI algorithms analyzing real-time data on wind, tension, and positioning. Engineers first built the bridge virtually, assembling every truss and cable in digital space before construction began. This simulation process, known as cloud-based pre-assembly, identified stress points, optimized materials, and eliminated design errors. Once validated, the virtual model guided automated machinery on site through a synchronized data system linking all equipment to a single control center. The bridge required the installation of 93 steel truss segments, each weighing up to 200 tons. Traditionally, such a task demands hundreds of workers and months of manual alignment. But using Beidou-guided automation and AI-controlled hoisting, the system positioned and secured all 93 segments in just 73 days, an unprecedented speed. At the center of this operation was an intelligent cable hoisting platform, equipped with gyroscopic stabilizers and AI correction modules. These systems constantly recalculated wind sway and cable tension, automatically adjusting to maintain the suspended steel trusses at a perfectly level position. Human operators monitored progress from a digital console, intervening only when necessary. The bridge's monitoring system is equally advanced. Over 400 sensors are embedded throughout the structure, in its towers, cables, and deck, continuously measuring temperature, stress, and vibration. The AI system processes this data in real time, detecting even the most minor structural changes. During load testing, 96 heavy trucks, totaling nearly 5,000 tons, crossed the deck simultaneously. Every sensor reported within expected limits, confirming the structure's integrity. To maintain safety in such extreme conditions, China used automated assembly lines for cable production and AI-controlled transport cranes capable of operating in the high-altitude winds of Guizhou's mountains. These machines operated around the clock, their operations synchronized through Beidou signals to prevent collisions or delays. AI also shaped the bridge's aerodynamic design. Machine learning models ran thousands of simulations to minimize wind resistance and vibration. The final form, a slender, wing-like deck supported by high-tensile suspension cables, was selected by algorithm for maximum stability and efficiency. According to the Xinhua news agency, this 2,890-meter bridge, with a span of 1,420 meters, is also the world's largest span bridge to be built in a mountainous area. Surprisingly, this bridge is nowhere near China's next mega-project. The world was stunned when the nation announced plans to use automation to handle complex, high-risk operations at speeds once thought impossible. China's mega railway. Chongqing, in southwest China, is home to over 30 million people. The city rises between steep mountains and deep river valleys, creating a striking landscape. For much of its history, this terrain made Chongqing one of China's most inaccessible cities. Even today, rivers cut through cliffs, skyscrapers stand on hillsides, and bridges span the mist-filled valleys. Beneath the beauty lies a constant challenge: staying connected. Chongqing's geography has consistently presented challenges to urban planning. Roads climb ridges, tunnels pass through rock, and districts are divided by natural barriers. Transportation here is essential. Early railways were slow and winding, with trains struggling through mountains and valleys. When China's high-speed rail era began in the 2000s, Chongqing joined the network, and Chongqing North Station became its main gateway. But as the city grew, the crowd soon overwhelmed it. Trains arrived faster than ever, but the old station could not keep up. Passenger halls overflowed during holidays, ticket lines stretched for hours, and travelers moved shoulder to shoulder beneath the glass ceilings. Expanding the existing stations was nearly impossible. The steep terrain left little flat land, and any large project would cost billions and cause years of disruption. At the same time, China's planners were preparing two major national projects. One aimed to link Chongqing and nearby Chengdu into a powerful regional hub, the Chengdu-Chongqing Twin City Economic Circle. The other was the 8 vertical, 8 horizontal high-speed rail grid, a plan to connect every major Chinese city through a single nationwide network. Chongqing's position made it central to both. Its location in the southwest placed it at a key intersection for several future rail routes. But the city lacked the capacity to match its growing importance. It needed a new hub, one that was larger, faster, and built for the decades ahead. In 1929, construction was approved for a new terminal on the city's eastern side, a station that would not only handle more passengers, but also serve as the heart of a new urban district. Work began in 2022, and after just 38 months, Chongqing East Station opened its doors. The scale of the new terminal is immense. It spans 8 levels above and below ground, with 15 platforms and 29 tracks, serving both high-speed and regular trains. Beneath them are metro lines, concourses, parking garages, and commercial areas, all designed to move people efficiently through the city. At full capacity, the station can handle around 16,000 passengers per hour. The design combines function with simplicity. Natural light fills the concourse through large skylights built into a wave-like roof that stretches over 120,000 square meters. The roof, weighing over 16,000 tons, rests on massive columns shaped like trees, a design inspired by Chongqing's city tree, the hanggu. These structures support the weight while creating open, light-filled spaces that reduce the need for artificial lighting. But Chongqing East is more than a station. It represents a new idea known as station-city integration, where transportation hubs double as complete urban centers. Surrounding the terminal is a 3.5-kilometer development called the East Station Hub New City, filled with offices, hotels, shopping areas, and public plazas. The goal is to create a district where people can live, work, and travel without long commutes. The project also helps balance the city's growth. By developing the eastern districts, Chongqing can ease congestion in older areas and open new space for business and housing. The station becomes not only a transportation hub, but also a catalyst for urban expansion. Building such a project was far from easy. The site faced extreme summer heat, often above 40 degrees Celsius, and uneven terrain that required massive earthworks. To keep up with the tight schedule, engineers turned to automation. Laser-guided bulldozers leveled the ground with precision. Robots handled concrete work and installed heavy glass panels weighing up to 800 kilograms each. AI-powered patrol bots traversed the site to identify safety risks. These technologies improved efficiency and safety. Construction speed tripled, costs dropped, and heat-related injuries were nearly eliminated. In just over 3 years, a complex project that once seemed unrealistic has become a reality. The architecture also makes innovative use of the landscape. The platforms are elevated, with metro lines, shops, and other facilities below. This Bridge Plus building layout creates around 400,000 square meters of usable space under the tracks and saves more than 20 hectares of land compared to a conventional design. Connectivity is at the core of Chongqing East. 4 metro lines will link directly to the station. Line 6 is already open, while lines 24 and 27 are under construction, and Line 8 is planned. This means passengers can transfer between high-speed trains and subways without having to go outside, a significant advantage during Chongqing's hot summers and heavy rains. The station also connects to buses, taxis, and long-distance coaches, forming a true zero-transfer hub for the region. City officials expect the East Station Hub to become a significant economic driver. New office buildings, hotels, and retail centers are already under development in the vicinity. The area is designed to stay active day and night, serving both travelers and residents. For daily commuters, the change is significant. A trip to Chengdu now takes about an hour instead of several. Business travelers can leave for Beijing in the morning and arrive by the afternoon. In the near future, residents from distant suburbs will be able to take a direct metro line to the station and transfer smoothly to their next destination. In size and capacity, few stations in the world compare. Grand Central in New York covers 190,000 square meters. Nagoya Station in Japan is around 410,000. Guangzhou South, one of China's busiest, spans 615,000. Chongqing East is even larger, one of the biggest single-station complexes on Earth. Its importance, however, lies in its connections. The station anchors the new Chongqing-Xiamen high-speed line, linking China's southwest to its southeastern coast. It will also connect to the Shanghai-Chongqing-Chengdu corridor and the Chongqing-Wanzhou line, tying the city to multiple national routes. Sustainability is also built into the station's design. Chongqing East meets China's top 3-star green building standard. Solar panels generate clean power, and large skylights reduce electricity use. The entire district uses a shared heating and cooling system for higher efficiency. Rainwater is collected and reused, while smart systems adjust lighting and temperature based on real-time conditions. Soon, China's colossal construction machines will think for themselves, powered by AI. When that day comes, they will reshape mountains, carve tunnels, and build cities faster than humans ever could. But what are these mega machines, and what makes them so extraordinary? China's King Track Layer. The CYP-500 track-laying machine redefines the pace of railway construction. Capable of laying 2 kilometers of track in a single day, it operates around the clock, turning a complex, labor-intensive process into a seamless, high-efficiency operation. In March 2020, the CYP-500 made its Southeast Asia debut on the China-Laos Railway. There, it installed a 500-meter steel track in Vientiane, marking the first section of the railway and the longest steel track outside China in Asia. The machine exceeded expectations, surpassing its daily target of 1.5 kilometers with ease and precision. Built for high-capacity, large-scale projects, the CYP-500 combines track laying, alignment, and precise placement into a single automated workflow. Its continuous operation minimizes downtime, while advanced control systems ensure rails are positioned with millimeter-level accuracy. The machine can handle challenging terrain, complex curves, and long bridges or tunnels, keeping even the most ambitious construction schedules on track. Over just 4 years, CYP-500 technology has increased China's track-laying capacity from 500 meters to 2 kilometers per day, setting a new global standard for efficiency and speed. And while the CYP-500 dominates rails, the secret behind China's record-breaking bridges lies in the next mega machine. The Iron Monster. The SLJ-932, known in China as the Iron Monster, is one of the largest bridge-building machines on Earth. It measures 91 meters long, 7 meters wide, and 9 meters tall, 580 tons, heavier than some warships, and one of the longest land vehicles ever built. Its purpose is singular: building bridges. Unlike ordinary cranes, the Iron Monster can handle entire bridge spans weighing up to 950 tons. It drives to a pillar, lifts a massive concrete beam beneath its frame, stretches it to the next column, locks it in place, and repeats the process until a bridge spans a valley or canyon. Its mobility is remarkable. 64 wheels pivot independently, allowing it to slide sideways with precision and position beams smoothly. Even fully loaded, it moves steadily, 5 kilometers per hour, and over its lifetime, a single machine can set 700 to 1,000 spans. The method is simple but revolutionary. Expansion joints connect each span, creating continuous, durable bridges that are far faster to construct than traditional bridges. Fewer workers are needed, smaller parts are unnecessary, and risks are reduced. Each unit is rated to carry loads heavier than any train that will cross its bridges, and skilled crews operate it with precision and expertise. What once took decades can now be done in a few years. Across China, Iron Monsters have helped expand the high-speed rail network past 30,000 kilometers, building bridges at a pace unmatched anywhere in the world. Engineers once doubted it, but it works efficiently and reliably, making traditional cranes look small in comparison. If the Iron Monster impresses, the next machine, a mega transport erect system, promises to push bridge construction even further. Kunlun. Named after one of Asia's most extensive mountain ranges, the Kunlun was developed by China Railway Construction Corporation, limited to lift and position massive box girders over mountains and rivers with precision and efficiency. It is the world's first transport erect machine capable of handling a 1,000-ton box girder, performing the work of 3 traditional machines. Kunlun can operate on slopes up to 30 degrees and navigate tight curves. It erects girders of 24, 32, and 40 meters, using high-strength steel that makes it both lighter and stronger than conventional equipment. In June 2020, Kunlun completed its final heavy-duty test and soon lifted the first 1,000-ton girder for the Fujian-Xiamen high-speed railway bridge, a 15-kilometer cross-sea span completed by September 2023, far faster than the Golden Gate Bridge. Its ability to place massive girders ensures high-speed trains can operate safely and smoothly at 400 kilometers per hour. Kunlun also uses advanced technologies. Laser systems guide it through tunnels, while real-time monitoring tracks the positions of the girder. Automated transport and placement integrate with railway management centers, improving safety and efficiency. These features reduce costs by about 20%, speed erection by 25%, and require less space than traditional machines. The machine has proven versatile in multiple projects. On the Zhengzhou-Chongqing high-speed railway, it worked on steep ramps and tight curves in rugged terrain. On the Fuzhou-Xiamen railway, it placed 1,000-ton 40-meter girders, improving navigation, reducing tidal impact, and enhancing bridge safety. Kunlun turns complex, dangerous construction into routine work. It redefines what high-speed rail bridge construction can achieve. And if Kunlun impresses, the next marvel, the world's most powerful crawler crane, pushes the limits even further. The mega crane. It seems almost unimaginable for a crane to lift 4,000 tons, extend a boom 144 meters into the sky, and weigh over 5,300 tons, enough to hoist a fully loaded Airbus A380 with ease. Yet this is the XGC 88000, an ultra-heavy crawler crane built by XCMG. Introduced in 2013, it became the largest tracked mobile crane in the world, surpassing the Liebherr LR 13000, and ranks among the largest self-propelled ground vehicles ever built, even outsizing NASA's famed crawler transporters. While the Honghai crane still holds records for sheer size, the XGC 88000 is unmatched in mobility and versatility. The machine has two main sections. The first is the crane itself. Its maximum boom reaches 144 meters, with an overall length of 173 meters, a height of 108 meters, and a lifting capacity ranging from 3,600 to 4,000 tons, handling overloads up to 4,500 tons. It produces a lifting moment of 88,000 ton-meters, powered by 3 Cummins engines producing a combined 2,579 horsepower, driving the crane and supporting assembly or backup functions. The operator's cabin is the size of a small office, equipped with air conditioning, a spacious seat, and even a sofa for 3 passengers. The second section is the tracked counterweight compartment, standing 9.7 meters tall, 29 meters long, and weighing 2,900 tons. It has its own cockpit and requires a working radius of 29 meters. Together, the crane weighs nearly 5,400 tons, a machine of unprecedented scale. Built for the petrochemical, nuclear, and chemical industries, the XGC 88000 handles massive components with remarkable precision. Its boom is adaptable, a 120-meter heavy boom, a 140-meter light boom, and an optional 33-meter jib. This flexibility allows it to operate in nearly any construction scenario, maintaining complete load shift and maximum efficiency. Since entering service, the crane has lifted modules larger than small buildings, performing moves that would leave conventional cranes struggling to handle. Watching it in action is like watching gravity itself bend, a performance decades ahead of Western engineering achievements. And while this crane dominates the skies, China's ambitions extend even further. The next spectacle lies in a task most would consider ordinary: concrete pumping, transformed here into an extraordinary feat of scale, pushing the limits of national engineering once again. The Pump King. When constructing the Shanghai Tower, workers faced a challenge that would overwhelm most equipment: pumping concrete nearly 2/3 of a kilometer into the sky. Western pumps would stall after a few hundred feet, but China's Sany 86-meter pump broke the limits, sending wet cement 621 meters high, higher than the Eiffel Tower, earning the nickname Pump King. As of 2024, it holds the Guinness World Record for the longest truck-mounted concrete boom. Its success comes from meticulous design, advanced materials, and precise engineering, redefining what is possible in high-rise and large-scale construction. The pump's boom has 7 sections, which are longer and more flexible than those of conventional 5- or 6-section designs. This allows operators to reach confined urban sites and complex terrains with ease. Made from high-strength 1,800 megapascal steel, the boom remains stable under immense pressure during extreme high-rise pumping. Mounted on a 9-axle all-terrain chassis, it offers both mobility and stability, thanks to advanced suspension and multiple steering modes, including crab and diagonal steering, for precise maneuvering in tight spaces. Operating the Pump King is equally remarkable. Its automatic boom system enables one-touch deployment, vertical and horizontal pumping, boom locking, and area limiting. Stabilization reduces boom shaking by 50% and cuts the swinging range of the revolving tower by 60%, ensuring precision and safety. Energy-saving technology boosts efficiency by 25% while reducing fuel consumption by 10%. The self-diagnosis system can detect over 150 types of malfunctions, minimizing downtime. Durability is also central to its design. The pump's piston can handle 25 to 30,000 cubic meters of concrete before replacement, and components made from advanced Sino-German materials resist wear and tear. The next machine is even more astonishing, and the first of its kind anywhere in the world. Wall climbing giant. Towering more than 40 meters high and weighing nearly 2,000 tons, the Baonaut was engineered to transform the way skyscrapers are built. Designed for speed and precision, it completes a new floor in just 4 days, more than 20% faster than conventional construction methods. Unlike traditional cranes, the Baonaut needs no external scaffolding. Its reinforced steel frame, powered by advanced hydraulic and automated systems, lifts and assembles massive prefabricated panels and beams with unwavering stability. A network of sensors continuously monitors stress, tilt, and load distribution in real time, ensuring flawless alignment even at extreme heights. What sets it apart is its vertical climbing system, a self-elevating mechanism that allows the entire structure to rise floor by floor without disassembly. Hydraulic jacks and counterweights maintain balance during ascent, while intelligent controls adjust for wind pressure, structural shifts, and uneven loads. This seamless motion keeps the Baonaut building upward without pause. Its rhythm is steady as a heartbeat. Every movement is guided by automation. Integrated sensors and precision software measure and align components to the millimeter, while intelligent algorithms make micro-adjustments automatically. From a secure control cabin, operators oversee the entire process, monitoring load, balance, and assembly in perfect synchronization. Constructed from lightweight, high-strength materials commonly used in aviation and submarine design, the Baonaut's frame features redundant stabilizers and counterweights that keep it anchored even in hurricane-level winds. It can lift, align, and assemble multiple structural elements at once, accelerating construction while keeping workers safely out of harm's way. Thanks for watching. Now check out the videos popping up on screen for more unbelievable stories.